Building a planned life cycle management approach early in the acquisition strategy of a program will definitely help optimize a platform or an asset useful life over time.
The old phrase, 50% of maintenance is caused by 50% of maintenance, is as true now as it used to be. You don't want to take parts off if you don't have to, and you don't want to make bad calls.
And so by replacing the vast majority of that older analog equipment with all new digital equipment, we greatly improve the mean time between failures.
To effectively sustain their aviation fleets, militaries must embrace a range of different sustainment approaches. Seeking out and understanding such tactics is crucial given the need to ensure force readiness for future threats. Welcome to Shepherd Studios' Critical Care podcast, the story of military aircraft sustainment and support in an unpredictable world. We're brought to you in partnership with our sponsor, Collins Aerospace. Throughout 4 episodes, we look at the role of sustainment in ensuring fleet readiness, consider the part that technology plays in reducing downtime, and hear about the advantages of greater collaboration between industry and the military. And we consider the future, how ever-changing requirements and new technologies are changing the game further. In the first episode of this series, we heard how militaries ensure fleet readiness through effective sustainment strategies. In this episode, we look more closely at the benefits of these approaches, examining the key lifecycle cost considerations. And we hear how scheduled platform upgrades can help avoid the critical impact of obsolescence on readiness. Of course, aviation sustainment challenges are nothing new. They've long been a focus for such bodies as the US House Armed Services Committee, which has a Readiness Subcommittee. Speaking before the subcommittee back in 2017, Lieutenant General Chris Nolan, who was then Deputy Chief of Staff for Operations for the US Air Force, outlined the readiness challenge.
We are quickly approaching an inflection point. 26 years of continuous operations have taken a toll on the force, and adversaries are beginning to close the technological gap. Today, our combat-coded units hover around 50% readiness rate to meet global demands, specifically for high-end conflict against near-peer adversaries. In short, the Air Force is too small for what the nation expects of it. The Air Force received $5.6 billion in the fiscal year 2017 request for additional appropriation, and we spent it wisely. We were able to fund our top priority affecting readiness, growing the force. The funding allowed us to recruit 4,000 additional active duty airmen, which we are using to accelerate readiness recovery by getting our planes back in the air. We made investments in pilot production to address our most critical shortfall, and we outfitted our battlefield airmen with the latest equipment to make them more lethal. We upgraded our fleet's targeting capabilities and increased munitions production. These investments will arrest our readiness decline in several critical areas, but shortfalls remain in the near term.
So what impact can effective sustainment have on the military mission? How does it directly support aviation fleets? This is Mike Moody, Manager of Integrated Product Support, Future Vertical Lift at Bell.
Sustainment is really the driver of the next operation. So our ability to deliver aircraft that are capable, that are easily maintained for the next mission, that reduce the burden on the maintainer, that reduce the log footprint in faraway places, that lower life cycle costs, that reduce risk in the overall operational context are all driving forces in the way we look at sustainment and maintenance of these aircraft. So cost and operational capability really make a difference in how a customer can behave when he's employing your asset wherever that may be.
It's vital to prioritise lifecycle management. This can optimise an aircraft's life over time if built in early to the acquisition strategy. Original equipment manufacturers such as Collins Aerospace can help implement such programs through the use of approaches like performance-based logistics, or PBL, a proactive sustainment approach that reduces lifecycle costs while boosting mission readiness. Francis St. Louis is Associate Director of Sales and Business Development for Asia Pacific at Collins Aerospace. He outlines the benefits of life cycle analysis and the impact such an approach can have on life cycle costs.
Building a planned life cycle management approach early in the acquisition strategy of a program will definitely help optimize a platform or an asset useful life over time. Doing these life cycle cost analysis can be achieved through engaging OEMs or system OEMs like Collins Aerospace for the implementation of sustainment programs, such as integrated logistics support, or ILS, or performance-based logistic programs, PBLs. This proactive approach to sustainment, has the objective to reduce life cycle costs while improving the mission readiness. And you do that through an increase of part availability. There's proactive obsolescence management. It gives you a better analysis of your component reliability engineering, the expert field service engineering that you need, as well as dedicated on-site training programs. So bringing the equipment or system OEM early into the acquisition process benefits the overall life cycle management strategy. This allows for a tailored sustainment approach to fit the customer goals and objective. And through this, you want to ensure that your return on your investment over the life of the asset or the program is as high as possible. So through a life cycle cost analysis, you're going to help your decision maker to make better decision in terms of increasing your return of investment over the life cycle of the asset.
What factors should an operator consider when looking at life cycle costs? It's important to conduct an economic analysis, setting alternatives to assess and compare the impact on future costs.
So, high level, the major component of a life cycle cost analysis should include, the initial acquisition of the system or the platform or the asset. What are the integration costs, testing costs? What spare level do we need? What kind of maintenance we'll need to do during the life of the asset or the platform? You need to cater for the repairs. Something that is often, or not, I should say often, sometimes it is skipped over, is all the training, support, and documentation. If you want to have success and make sure that you don't keep repairing an asset or a system all the time, catering for training in your life cycle costs is very important. Another variable to consider also with what is the involvement of program and supply chain management, some of the operating costs over the life cycle costs, modernization and growth of the solution. As we know, we're not, usually when you do a life cycle cost analysis, you're not buying a system or an asset just for a few years. It's over a longer period of time. So over a longer period of time, technology is going to change. So in a life cycle cost analysis, you need to cater for modernization and growth. And also you can look at disposal at the end of its useful life. So in order to build a life cycle cost analysis, two things very important. First of all is the gathering and validating the data that you need to build your model, but also to make it clear what are the assumptions that you take. This is very critical.
With so much to consider, it's vital to tailor a life cycle cost analysis to the individual needs of the user. This is a crucial consideration for Collins Aerospace.
Yes, at Collins Aerospace, when we work with customers to prepare life cycle cost analysis, we tailor it to the need of the user and what exactly they want to procure. So it is a very tailored approach. So lowering that life cycle cost can be straightforward and a direct measure of economic value to stakeholder. But the way that we like to working with our customers to really understand what are their needs, their problem to solve, and see how can we help them build that matrix or that life cycle cost analysis to respond to their needs. So at Collins, we use this approach as a trade-off technique or matrix to assist our customer in understanding the value of one solution over another. So we help customer build their matrix, and they can use it to do some comparison with other vendors in procuring a system or an asset.
Francis St. Louis is based in Singapore, an important part of the rapidly growing Asia-Pacific market. The country's experience is a good example of how a strong knowledge of life cycle costs can positively impact a military operator. Singapore's Defence Science and Technology Agency, or DSTA, is responsible for performing acquisitions management, systems management, and systems development for the Singapore Ministry of Defence and the Singapore Armed Forces.
So it is of public record that in Singapore, for example, the acquisition or the procurement authority, so Defence Science and Technology Agency, or DSTA, they use an adaptation of a life cycle cost analysis for some of their major procurement, which is called an analytic hierarchy process. And that's a variation of a life cycle cost analysis where it gives an evaluation framework and acquisition strategy to measure the total life cycle cost and the program benefit of each proposal they receive. And that helped them to do an objective and quantitative evaluation. Then after that, the benefits are subsequently weighted against the program cost, and each proposal is then compared, and they get this data to make their decision.
While Asia-Pacific is a crucial focus for aviation providers across the board, it comes with its own unique trends. This is certainly true when it comes to sustainment needs and strategies.
So some of the trends that we see in Asia Pacific. So for most countries that are outside of the US, we see challenge like availability of spare parts, especially if they come from a US platform. It can be challenge or that obsolescence management or obsolescence issues. So that can be a challenge for operators in Asia Pacific. Obsolescence management is a big challenge for operators in the region. And also, last one that we see is sometimes accessibility to technology. Sometimes it is limited by products or systems or parts that are controlled by ITAR in the US. It is a challenge to have access to that technology, and not every country can have access to that technology.
Each country operates its own defence context, and Singapore is no exception. The country has historically been a heavy investor in defence, and today has a successful aviation sector, notably represented by the Singaporean aerospace and defence company ST Engineering. The city-state has learned significant lessons over the decades, some of them painful. These experiences have helped Singapore adapt aircraft operations and sustainment needs for the Southeast Asian climate. Let's turn to Asia-Pacific aviation journalist Chen Chuan-Ren for more.
Singapore, the Air Force is 50 years old, and they have learned so much from the earlier years. During the start, we procured ex-US Navy Skyhawks, and they had a very painful lessons from the Skyhawks. I think they call it the Black Week, whereby there were a few crashes and lives were lost. And then from there, that's where they developed knowledge, new practices, how to adapt Western-made aircraft into Singapore, Southeast Asian climate. How do you adapt your working practices. Like for example, Singapore servicemen, they might do things differently from overseas or Western counterparts. So it is years and decades of experience. Again, as I said, painful experience sometimes, but all these lessons are well learned over the years.
Singapore is one of many countries that has turned to performance-based logistics contracts to help support military fleet readiness.
Some of the major PBL contracts are all with ST Engineering. So you have the C-130s, where the ST Engineering will also participated in the upgrading of the aircraft, avionics, wind structures, etc. The Super Pumas, formerly the KC-135, and now the Airbus A330 MRCT tankers. They are also participating in the Fokker 50, as well as the F-5 fighters. Again, ST was involved in the upgrading of the aircraft, and following which the PBLs of the aircraft as well. Easily half of the fleet, support aircraft as helicopters are all supported by PBLs, and I think it gives the Singapore Armed Forces or the Air Force a bit more bandwidth, in terms of their allocation of resources. After all, Singapore is still a conscript armed forces. Your maintainers, your crew chiefs, some of them are what we call national servicemen. And, they are there for 2 years, 3 years, and come back every now and then for reservists. So you need to have a very stable and sustained level of standards when it comes to servicing the aircraft. So I think the PBLs are a good way to do that. You have a dedicated company, which is ST Engineering, to look after that for you, and you leave the ST Engineering to work out the nitty-gritty business stuff with the manufacturers, for example. So I think this has gave the Air Force a bit more bandwidth, more time and resources to do warfighting training, flying, and use the crew to better use and enhance their career prospects as well.
Singapore has used PBL predominantly to support its F-15 fleet. The approach is also likely to play a key role in the future through the country's F-35 acquisition.
Looking at how the Singapore Air Force is using the F-15s, you can tell that they are very happy with the sustainability of the aircraft and, of course, components. So a good example is the Singapore Air Force is operating in 2 locations at any one time. In this case, Singapore and Idaho in the United States. So, of course, you can easily get parts from the United States, but Singapore is, of course, a different story. But you also have to understand that every now and then, Singapore conduct overseas exercise in Australia and Guam. I think, if my memory serves me right, right now, there's a detachment of F-15s in Darwin, Australia, and they have been there for weeks. And the flying intensity is very high. And similarly, they are flying, doing so in Guam with our F-16s. I don't think there's any issues with their PBLs, and I think that will happen for many years to come. The F-35s will be a very interesting creature because, firstly, our F-35s will be based in the States for training initially. So naturally, again, you have local contractors, Lockheed Martin, supporting the fleet there. But once it comes to Singapore, I think PBL will be a good way to lock down the OEMs into the fleet. But what I'm curious is about how it will work together with the spare pooling system in this part of the world. Because right now, there's in terms of the Bs, there will be Singapore, Japan, and Korea. So in terms of the mass, it's not as big as compared to the F-35As in Europe, or not even in Asia. There's only Japan and Australia that's operating the As. So I think PBL is a good way to overcome that, but I think it's still too early to tell because no doubt we'll get our first jet in 2026, but I don't think that might kick in much later, say 28, 29, when it's based in Singapore.
Bell's approach to sustainment support and lifecycle costs has been developed and refined over many years, with around 12,000 Bell-designed aircraft currently in service around the world. Here's Bell's Mike Moody again.
One of the advantages of being in this space for this long, and certainly in the tilt rotor space, is understanding all those challenges that are in the enduring fleet. For example, the V-22 has almost 700,000 hours on it. So at this point, we understand what those challenges are, and we can make a deliberate focus on addressing those challenges and correcting those actors out there long before they make it into the field. So all those things, understanding what the challenges are involving maintainers in the design process, looking worldwide to how our aircraft have performed in a variety of environments. All those, I think, are part of our approach to providing to our customers a sustainable, maintainable, and lower life cycle cost as the aircraft enters into service.
Bell's customers and potential customers are increasingly focused on the entire lifecycle cost of their platforms. This is connected to their ability to operate remotely in a disconnected environment and to cut back on the logistics footprint, easing the burden on the maintainer.
Bell's approach is to include supportability and sustainability in our baseline design processes. So what that means at that point of the spear, if you will, is that maintainers and sustainers are included in design elements early on in the program. So we ensure maintainers' equities are supported in the design process. They're included in what we call fly-throughs, and that is during design, looking at component placement, component reliability, system strategies, and things like that. Not only is that the purview of engineers, but it's also the purview of journeyman maintainers who have worked in this field for their entire life. So it's a great mix and a great approach that Bell's taken to ensure that the guys that have to sustain that aircraft once it gets in the field are included early in the design process. Lots of conversation, as you can imagine, lots of equities at stake. We win a few, we lose a few, but in the Bell process, those maintainers, their voice is always heard. Even at the end of my career, sustainability and life cycle approach was beginning to come to the forefront because you had, capability is not is absolutely critical, but the year-to-year costs of an aircraft really drive, budget. 60 to 80% of life cycle cost, for an aircraft is in the operations and support timeframe. So you have a very little cost up front, but the real life cycle cost is after it gets to the field. So certainly, United States Army and the Marine Corps and Navy are very, very attuned to what is the life cycle cost and what is the frequency of maintenance. How are you addressing your contributors to cost per flight hour, to non-mission capable times and maintenance man hour. So I think it's ascendant, and it's certainly a very, very large part of the conversation that we have with our government customers and potential partners now. So I just think it's more and more important now as we move into the environment that disconnected operations, and certainly everything is so much more expensive now than it ever used to be.
Fleet readiness depends on the availability of spare parts. However, this is just one part of the broader picture. It's vital to understand what's driving cost and readiness and address those elements in the design process, particularly for newer aircraft.
But it's not only the reliability of those parts, it's the entire system in which they operate. So once you have designed and built the best part you can produce in industry, and that's Bell's calling card. We produce great components, and we produce those components that drive readiness. You also have to tie that to inspection and maintainability and diagnosis of problems. In other words, what is the time required to inspect a component? How invasive is your inspection and maintainability strategy on that aircraft? How long can you watch that component degrade until you have to replace that? Does that component degrade gracefully and predictably so you can keep that component on wing longer? When it's time to replace that component, how easy is it to replace that component? Have you placed components that fail more often in the most easily accessed places, within the design of the aircraft, or are they tough to get to? Do you have to break other systems to get to those components? All of that is a focus really going forward, and knowing, truly understanding the health signature of your aircraft, making repairs and inspections as easy as possible, enabling the maintainer through interactive electronic technical manuals to make the right call, improving your fault to fix logic trees so that when you pull a component off and you order it, it's the right component each time. And then develop those training systems that enable your maintainers on your aircraft to be as informed as they can be, so that they don't break components pulling them off. The old phrase, 50% of maintenance is caused by 50% of maintenance. It's as true now as it used to be. You don't want to take parts off if you don't have to, and you don't want to make bad calls.
With digital maintenance and other technologies continuously advancing, what does the future hold for sustainment?
I am most excited about our ability to put the right tools in the hands of maintainers at planeside, wherever they may be. So it is, they're wonderful, guys and gals in all the services and maintaining the aircraft, but without the right tools at planeside, it becomes problematic. But I think Bell is doing just a wonderful job at ensuring that we can deliver processes, better fault to fix decision trees, better electronic technical manuals, better diagnostic processes. When I look back to my career, especially in the Army, and I see a poor guy out there with a 4-inch binder, and he's trying to flip from page to page, trying to trace an electrical circuit in the electrical system. Those days are over, and now you can deliver a much more intuitive system to those maintainers right there at the point of the spear. And it's all about that. It's all about enabling those guys to fix that aircraft, maintain the aircraft in challenging conditions worldwide.
Technological developments, notably in terms of sensor development, are also providing a significant boost to fleet readiness efforts. Mark Ballou is Senior Director for Global Sales and Marketing for Boeing's International Government and Defence business. Here he outlines how such advances are supporting the CH-47 Chinook.
Certainly with the Chinook, we've had sufficient life of the aircraft to say, hey, here's the areas we know that you're going to have higher failure rates, or things that are causing vibrations, could be causing cracks, or could be causing different types of things. So we've put sensors and things in those different areas to be able to give us an indication of things going on. So you can do any maintenance that we required or any of the work on that before it gets to be more of a significant issue, and you're having to do more of a thorough tear down the aircraft to be able to make those types of repairs. So all those things have taken that historical knowledge of, hey, where have you had potential issues or things that are growing up that you should increase your attention to. We put those sensors, accelerators, whatever it is in that location to be able to do that. That's getting us information ahead of time. We're staying in front of it. We're also saying, again, as opposed to just using the engineering design work for this, the parts components, they give you information. And it's just a matter of being able to evaluate and review that and say, hey, I don't need to go make a change or an adjustment now, or I've got enough of an indication there that I need to go take a look and see what's going on. So that's helping with the longevity. And again, getting into the reduction of the flying hour cost and the total life cycle cost of the aircraft.
any conversation about the sustainment of military aircraft invariably touches on the issue of managing obsolescence. Here, upgrades and modernisation are crucial, ensuring that long-serving aircraft can continue to play a vital role. Indeed, upgrades can help solve a range of issues, resolving obsolescence and improving military capabilities.
Aircraft are aging, so they have obsolescence issues, obsolete equipment. They also have a need for unique military capabilities beyond getting from point A to point B, some unique military capabilities that those end users need.
This is Les Worley, Business Development Manager at Collins Aerospace. A partner like Collins can help operators determine how exactly to pursue the work, ranging from relatively simple upgrades to a much larger scale effort.
We have equipment out there that's over 30 years old that we're still repairing, that it too will reach a point that we cannot get the components to repair that individual box, and it will have to be replaced or the system replaced. So we might be able to take that one line replacement item, LRU box per se, and pull out the old processing card and put in a new processing card. Pull out the old video card or video chip and put in a new one, and the box itself basically remains the same. We can do that on a case-by-case basis, but again, eventually we will reach the point that those components are no longer made, and it is much more efficient just to replace the entire avionics box and or system. Within an avionics system, there are so many pieces of equipment, from the displays that the pilots are looking at, to the communications equipment, to the autopilot on the aircraft. So sometimes you find that, okay, I can upgrade this one box, I can fix this one box, but now it doesn't integrate, it doesn't talk with all of the other older boxes that are on the aircraft that are working fairly well. But I really have to replace an individual piece, an individual component, and now I have an integration issue of the other equipment on the aircraft that might be a forcing point to replace more than one box.
Today, aviation crews must deal with more data than ever before, something that will only increase in the future. Processing this information and making it accessible for pilots and other personnel is a crucial focus for upgrades.
We're trying to get to the point where the pilots are not constantly talking on the radio to get the information, and then they have to picture it in their head where that other aircraft is. We want to put that information on their display, whether that's a multifunctional display next to their primary flight display. It might be in the center console. So tactical information coming up to the aircraft is very important in a training or a combat situation, where they can actually see a map of the area, and they can see their position, and they can see friendly aircraft around them. They can see non-friendly aircraft. They can see threats on the ground. All of that information needs to be displayed to the pilots, so they, at a snapshot, they can look at it and get their situational awareness. So we want to get more information. In order to do that, we need displays at the cockpit, and the larger the display, the more information we can put on it.
Collins has addressed this need directly through a range of systems, perhaps most notably its Flight 2 integrated avionics system. Les Worley explains how this technology can help address obsolescence issues and help maintain fleet availability.
So we designed and developed back in 1999 an avionics system, an avionics suite of equipment that we call Flight 2. It's still flying today. And we called it Flight 2 for the second century of flight. And this new system transformed the cockpits of the 60s and 70s into the cockpits that we see today. So we've talked about older equipment, all of these standalone analog gauges, individual gauges, one for fuel, one for oil, one for your situational awareness, your HSI, your ADI. And none of those instruments talk to one another. That's why we had so many of them. So the pilots are constantly scanning the cockpit, looking and reading those instruments. So when we developed this Flight 2 system, we removed those analog gauges. Just in the C-130, for example, just the engine gauges are 32 gauges that the pilots have to scan and monitor, and now can be removed. We did that with Flight 2. It's a digital system. It's an integrated system. The boxes are no longer individual boxes. They talk to one another. They are sending that information up to those displays that we talked about, whether it's a primary flight display or a multifunctional display. So that information is now being transmitted to the pilots, maybe additional crew members. And we basically transform the way that avionics had been developed over the years with this new system called Flight 2.
Military aircraft have a range of unique operational demands which must be supported throughout their lifespans. Here's Les Worley again, using the C-130 as an example.
C-130s carry cargo from point A to B, and they also drop cargo and paratroopers out in flight, both at high altitude and low altitude airdrops. We have designed into our flight management system an airdrop function that calculates the drop point for the aircrew. So whether they're dropping cargo or paratroopers, it assists them in a precise drop point so they can hit their target point and get that cargo or paratroopers where they need to be safely. Other things that military aircraft do and need to do that commercial aircraft do not, and that is operate in austere locations. So we don't always have the luxury, especially in a contingency or a combat operational area, to land at a nice airport and runway, concrete with lighting. Sometimes we need to land in austere locations, and that might be a dirt road. It might be a piece of flat land in a desert. And so our air crews need to do what we call a tactical approach. And our flight management system allows them to calculate that. It allows them to put in navigation points that will determine where that aircraft should start down in its descent, because there's no aids on the ground to tell them. It will tell them where their touchdown point should be and where their rollout point should be in this airfield that doesn't exist. So those types of capabilities, additional capability, those come along with our system.
Crucially, such upgrades can increase the mean time between failures. Essentially, this means pushing down the failure rate, a key demand if militaries are to boost fleet readiness.
So how often does that piece of equipment or system, maybe it's 2 or 3 pieces of equipment, how often do they fail? What's the mean time between the failure rates? And the older equipment, fails at a much higher rate than the new digital equipment. The new digital equipment like your computer and your laptop. And so by replacing the vast majority of that older analog equipment with all new digital equipment, we greatly improve the mean time between failure. We also, when we do a major avionics upgrade, not only do we remove all of those old analog gauges, we remove the old copper wiring that's in the aircraft. It's all stripped out. So a good comparison here would be for people listening, whether it's their parents or their grandparents, if they can remember those old CRT, cathode ray televisions that we had. Not near as big what we have today, right? The 60, 70, 80-inch TVs. But these, if you had a 36-inch TV, a 40-inch TV CRT, that was a big TV, and it took 2 big men to move it. Very heavy equipment. Same thing kind of applies to the older analog avionics equipment on aircraft. much heavier than your digital equipment that we have today. When you remove that old equipment, replace it with lighter weight digital equipment, you remove the old copper wiring and you replace that with newer lightweight copper and aluminum wiring. You put that back on the aircraft. When an aircraft goes in for a major modification, it's weighed, and when it comes out, it's weighed to make sure they understand where the CG is on the aircraft. And we did that on an aircraft and determined that the weight reduction was about 1,000 pounds, just in equipment weight and wiring weight. That equates to fuel savings on every flight and significant fuel savings over the life of that aircraft.
The relationship between supplier and operator is a key focus. Collins Aerospace aims to build a strong internal service and repair capability for its components, becoming a trusted partner for its customers.
Some of the aircraft that we are upgrading today are over 50 years old. And I'll give you two examples, the KC-135 and the B-52. Aircraft over 50 years old, and the services have said they're probably going to fly some of those for another 50 years. So with systems like our Flight 2 products and systems, we want to make sure that we're hand in hand with those customers to help them sustain those aircraft so that they can fly another 50 years. We have a number of people in our military avionics business unit at Collins that are former military operators, whether that's they were a transport pilot, they were a tanker mechanic, whether they worked in the headquarters. So we have the huge advantage that we have that relationship built in with a number of the people that we have hired over the years, that they continue those relationships with colleagues that are still in the services or in other companies. You know, we have to have that trust not only with our end customers, but also with those other equipment manufacturers that we're working with.
In episode 3, we'll take a closer look at the importance of collaboration between industry and government operators. For now, let's turn to Francis St. Louis and Mike Moody for some final thoughts on how companies can support their military customers throughout the lifespan of their aircraft, providing a platform for fleet readiness across many years and decades.
I think we see a trend to be successful is through partnership and collaboration. There is a trend in the industry right now, and I can see it a lot in Asia Pacific, where countries are looking for localization for sustainment. So this is something that we do at Collins Aerospace, working with customers and trying to understand what's their need and see if there's something that we can do to help them.
I think the JMRTD process, the Joint Multi-Role Technology Demonstrator process, was a wonderful example of collaboration and communication between OEMs and government, and of course can only speak for Bell. But as I joined the program, I've been nothing but impressed with how candid and open the Army was during that process, and I think that process continues. The collaboration, can lead to a greater understanding of what requirements are, and that's always essential, going forward. It builds an element of trust. Certainly there's always the division between OEM and government, but I think that communication, open communication, transparency was key and essential to the success of JMRTD and the other programs going forward. Our approach and strategy is that we don't want to be a unicorn on the battlefield. We don't want to show up with something that is not interoperable with the existing Army and DoD enterprise information system. So that candor in working with an environment, knowing that you're not the only airplane on the battlefield, and that maintainers, for example, that are supporting a a Enduring Fleet platform on one side of the airfield. We'll walk over and support a Ferroflora platform the next day. Really makes you, sit up and take stock of, hey, this is the training they come to us with, and we want to make that transition as seamless as possible. So working with government through all those has been very helpful.
One thing that industry can do to help is to look into how they can support, let's say, local repair facilities in Asia Pacific, for example, to meet the need of the customer to have more local, but also through collaboration and partnership. It is also a key to success in order to be close to the customer, to understand their need, is to see how you can work, partner, and collaborate with the different organization or the different industries in the country.
The Critical Care podcast was produced by Shepherd Studio in partnership with Collins Aerospace. A huge thanks for their support. Thanks also to everyone who provided their time to support the project. The Critical Care podcast was produced by Tony Skinner and Jack Austin, with research and interviews by Damien Kemp and scriptwriting by Jared Cowan. Until next time.